Okay, so then we get to example number 3. And in example number 3, this is not a linear system, right? Because this is y equals x squared. That's a quadratic. What's a quadratic going to graph as? Parabola. So if I think about the possibilities for a line in a parabola, I might get one intersection or no intersection like we saw before, but I might also get 2 intersections. They'll bring back anything that we've already learned this year. We've learned both circles and parabolas, so they could give me something like this where I get 4 intersections. So if you get more than one intersection, don't think that you've done something wrong. All right, remember we said for substitution, you can solve either equation for either unknown. Here's where we need to work smarter, not harder. Which equation do you want to work with, the first one or the second one? The second one. And do you want to solve for x or y? How come I want to solve for y? Because 2 reasons. If I solve for x, I'm going to get a fraction. Not a fan of that. And if I solve for x, I got to plug it in here and here. If I solve for y, I only have to plug it in here, right? So absolutely, I want to take that second equation and solve it for y. And as we said earlier, the whole idea of substitution is to take what we get for y and then substitute it into the other equation in place of y. So let's take what we just got, 2x plus 1, put it in the place of y in that other equation. Watch out that you distribute that negative, so we'd have negative 2x minus 1. Combine like terms. And they were kind enough to give us one that we could factor. Heaven forbid, what if this did not factor? Remember that thing called the quadratic formula? And remember that you do not have your graphing calculator for this test, so you do need to be able to do quadratic formula by hand other than using the program on your calculator. What if when you were solving here you got imaginary answers? If you get imaginary x's, how are you supposed to plug that in and find y's? Yeah, that just means that you don't have a solution. Exactly. All right, so we are going to take, as we did earlier today, our x's and plug them back in. And because we got 2 x's, we're going to get 2 y's. So we're going to get 2 solutions. So we're probably looking at a scenario kind of like this if we graphed it to check it. So we've spent a lot of time today talking about what one solution looks like or what intersecting looks like. So let's review for just a second what no solution or infinitely many solutions might look like. We just said no solution comes when you solve a quadratic and you get imaginaries. But another way that you get no solution is if when you're solving, if all your variables drop out and you're left with an untrue statement like 0 equals 6, that means there's no solution. If you're solving and all of your variables drop out and you're left with a true statement like 4 equals 4 or 0 equals 0 or x equals x or some type of an identity, that means that you have infinitely many solutions.